Hello guys, welcome back to my class. In this lesson, I'm going to show you one of the most important topic here, which is array. Okay, what is array? Array is the collection of a fixed number of elements of the same data type in the same identifier. And each element is basically accessed by using this index. And by default, this index is always start from 0. In these lessons, I'm going to cover only 1D and 2D arrays. Okay. So given these situations, Team Malaysia has scored this 7 score in archery games, and record down all the score in variables, so that analysts can retrieve the data for analysis. So in the previous conventional ways, we have to create 7 variables, right, with different identifiers to store these 7 different values. This is not effective. What if, let's say, we have 200 scores? Are you going to create these 200 variables to store each of these scores? You may find out it's very difficult to manage. So to overcome this limitation, C++ provides a solution where you can store 7 values inside one variable using array, as shown in this slide. Now I'm going to show you the proper way to declare and store multiple values into this array. There are 3 important terms when you are declaring this array. The first one is the data type for this array. The second one is the array name. Make sure that you follow the rules for this identifier, which I stated in the chapter 2. And the size of the array. Bear in mind, in an array, the array can store the multiple values from the same data type. If you declare char data type, then the value in this array can store only char. So in the case just now, we would like to store 7 values in the integer data type. So the data type here is integer. So meanwhile, the name, I give a name a score, as long as it is meaningful. And the size here is 7, because we have 7 score here. Okay, once you declare this array, and then 7 empty space will be created just like this. And each of the location here will be given an index number. And then this location 1, okay, location 1 will be given an index 0. Always start from 0 by default. And then the second locations will be having index 1, and so on. And the last location 7, we have this index number 6. So bear in mind, the index value is equal to the locations, or we call it as an element, minus 1. Okay, now move on to the initializations. To assign the initial value to this array, we need to use breaks with a comma. For instance, to store 7 values here, okay, you have to separate the values, each of the value here, by the comma. If you know exactly the size of your array, indicate the size during these declarations. Else, you can just leave it blank without indicating the size. Okay, but if let's say you have indicate the size, but somehow you just assign the sum of the initial values into this array, then the value for the other location here will temporarily store or fill up with this 0. You can just alter or assign any value during the runtime. Okay, so here I'm going to show you the example. If let's say I remove some of the value here. Okay, so now this is index 0, 1, 2, 3. Okay, so this is 4, means that it's location number 5, location number 6. Now I run the program. It will show me 0. Okay. To assign the value into the array, the most important point here is the index number here, or the number of elements. If let's say you would like to store a value 98 into the first location, and 88 into the 5th location. Do you remember the equation just now? Okay, the index equivalent to the locations minus 1. Okay, so before you store the value into this array, identify first what is the index value. Right, this first location is equivalent to index 0. Follow the equations. Okay, you have elements or location minus 1 will give you index value 0. Okay, So inside this array, indicate the 0. Then you are going to assign this 98 into the index 0. Same to the 88. If this 88 in the 5th locations, then index number 4. Then you are going to assign this 88 into index number 4. Bear in mind, the locations here is not equal to the index. Okay, the index 0 always start from the 0 by default. And then index 0, we have the first locations or first element. Okay, now here we have a different ways on how to store multiple values into the variables. Just a summary. The first way, you have to create a multiple variables and assigning each value to each of these variable, which is not efficient. So we should have to use an array where you just need to declare one time the variable and then you assign the value for each of these index, either using the basic initializations or compound type initialization using these braces and the comma. Alright, so I'm going to show you the most common mistake they make by the students. Okay, where they always are confused with this index and also the range, the elements, number of size. Okay, so look at this case. We are declaring the array's size of 10, which means that the index is from the 0 to 9. Has a size of 10, but the index starts from 0 to 9. But a lot of students that have a wrong interpretations during this value assignment. Okay, the value inside the bracket during this declaration is size, but the value inside the bracket during the assignment is index. Okay, and most of the time when the student assign a value to the last index, they always use the size number, in this case 10. Okay, where the C++ compiler will throw you the error because index 10 here refer to the location 11 or the element 11. Okay, it is out of the range. Okay, be alert of this size and the index. The size, the value that you put during this declaration is the size, where you have this index 0 to 9. Where the value that you put during this assignment, value assignment, it is actually the index value. Okay, make sure that it is within the range. Okay, so same as the normal variable, we can also perform the arithmetic operations in the array by indicating the array name and its element. For instance, we are going to add this index 3, which is location 4, 1, 2, 3, 4. Okay, you are going to add 5 into this element 4, 76. So 76 plus 5 will give you 81. Okay, and then you are going to divide this element. This is index 6. Index 6 is basically having the location of number 7. Okay, which is 78. 78 divided by 2, you will get 39. Okay, don't get confused with this index and the element. In array, we can't copy one array into another. Okay, in normal variable, yes, we can copy one value into this variable, but in array, we can't copy exactly the same from x to y. Just like this case, we have x, array x storing the 5 elements. Then we copy this x straight away into the y. No, we can't do that. Okay, in order to copy this value from this array x into the y, we have to use for loop. Okay, where you have to go through element by element. You copy this element into this y and then go to the next element, copy next element, and so on. You have to use for loops. Okay, so same to the retrieve the value or read the value, we have to use the for loop. Okay, in this case, you are going to read 8 values. Okay, 8 values from the user. You get the 8 inputs from the user and store into this array. Alright, so you have to use for loop. Start from the index 0. Okay, let's say the user key is 67, then you will store this 67 into the index 0. And then go to the next element, store 50, and then store 50 into the first element, and so on. Remember, in array, in order to read or to retrieve or to display the value, you have to use for loop. Okay, so now I'm going to show you how to use an array in this one of the applications. Okay, look at this questions. Prompt the user to key in a 5 sales value in a 1D array and perform the following operations. Okay, you are required to ask the user this key in the 5 values. Then you have to display each of the sales value, and then find the average value, find the largest value, and then finally find the tax amount for each of the sales value using the following formula: sales times 0.06, which is 6%, and store this value into the new array name known as the tax amount. Okay, and then display them. Alright, so to look at this is the coding part. Firstly, you have to create the array for sales and then the array for tax amount. We're going to store the tax amount for these 5 elements. Okay, and the first one, remember, in order to read the value in the array, or to get the user input, you have to use for loop. Okay, so I'm asking the user to key in a 5 value here. Okay, I run it. So key in a 5 value: 20, 35, 62, 42, and then 80 and 16. Okay, so I key in 5 value, I press enter. Yeah, then now move on to the display. To display the value, you have to use for loop also. Start from the index 0, so it will display the value for this index 0 and so on, index 1, 2, 3, 4, 5 elements. Alright, so same goes to this. To find the total, you use for loop, then you update the value for sum. Okay, initially you declare this sum as 0, and then you add this value from index of 0 into this sum, and then you update the value until the last index number, and then finally you get the average divided by 5. Okay, and we have to find the largest value. In order to find this largest value, you have to make some assumptions first. Okay, so in order to find the largest value among the arrays, or to find the lowest among this array, you have to make the first assumptions. Alright, okay, assuming that you have 5 value: 20, 35, 62, 42, and 16. This is index 1, 0, 1, 2, 3, 4. This is index. Okay, so first assumption, you have to assume that this index 0, which is 20, will be the largest. This is your first assumption. Okay, next one, you have to compare this largest and also the index 1. You compare this with this one. Is it 35? More than the largest? Yes, 35 is it larger than 20? Yes. Then you have to update the value for the largest. So now your largest will be equal to index 1. Next, you repeat the process. Now you compare this 62 to the largest. This will be your largest now. So is it index 2 more than your largest? Yes, 62 is larger than 35, right? Therefore, you update again. Largest equal to index 2. Okay, now this is no longer largest. Now your index 2 will be the largest. Okay, now this. Now you have to compare whether your index 3 more than the largest. So 42 is lesser than 62. Therefore, you remain the 62 as your largest. So this is not largest. Now finally, you compare the last index with this largest. Is this 16 larger than the 62? No. Therefore, this 62 will be your largest among all the values in an array. Okay, so when you convert this into the programming, this is how it looks like. I assign this index 0 as the largest first, then I compare. The first index, is it more than the largest? If yes, then I will update the value for the largest. Else, I will remain the largest value. Alright, then I keep repeating until I get the largest value. Alright. And then I have the last questions, find the text amounts. So basically this one is same like the previous one. You just need to perform some calculations. Okay, times 0.06, and then you reassign the answer for this text amount into the index, and then you display the value for the text amount using the for loop. Okay. Now we will move on to this two-dimensional array. Okay, it is basically an organized as matrix which can be represented as the collection of rows and the column. Okay, the declaration method is same as the one-dimensional array. Okay, you have to state the data type, the array name, and then the only difference here is the size. Okay, in the previous one we have only one bracket, but here we have two brackets indicate number of rows and number of columns. For instance, you would like to declare a two-dimensional array known as A with 3 rows and 4 columns. Then you have to put this size. You have 3 rows and 4 columns, right? So you just put 3 and 4. 3 represented row, 4 represented number of columns. Okay, again, each of the location or element has its own index. So you have 3 rows, so always start from the 0. So start from 0, this is the first row, and then second row, and then third row. Meanwhile for column, start from the 0, this is the index 0, we have the first column. Alright, then index 1 you have the second location, location 2, and then location 3 you have index 2, and the last location or last element we have the index 3. Okay, so to initialize a two-dimensional array, we have to use the brace and the comma. Okay, let's say you have 3 rows. Please specify the bracket value for each row. For instance, 0, 1, 2, 3. You put the bracket, represent these values are belong to the index 0, row number 1. And then 4, 5, 6, 7, another brace. Okay, another bracket. Okay, it represents index 1, row number 2, and then the last index 8, 9, 10, 11. Okay, so there is another way to initialize the value where you can just use a single brace to include all the values. Okay, for instance here 0, 1, 2, 3, 4 until 11, just put 1, include all the value into this one brace. So this C++ compiler will help you to auto compile this first 4 value as the first row, and then this 5, 6, 7, 8 as second row, and then 8, 9, 10, 11 as the third row. Okay, so to assign the value into the two-dimensional array, again you have to identify the element and the location first. In this case, okay, you are going to store the value 1 into the row 1 and column 2. This is the position, locations or elements. Remember what is the formula for the index and the row? Index is equal to location minus 1. So row 1 column 2, you have to minus 1 become index 0 and index 1. Then you assign the 1 into these positions. Okay, and then you have second value 6, you have to store into the row number 2 column number 3, which is index 1 and index 2. So put in index 1 index 2 equal to 6. You're going to assign this 6 into this array with having the index value of 1 and 2, okay, equivalent to location 2 and 3. Okay, so to process an array, remember we have to use for loop. In this case, you are required to calculate the total for the second row. Okay, so the second row is fixed. Okay, in this coding, you fix the index number equal to 1, which is equivalent to row number 2. Okay, then you start to use the for loop to scan through the row, to scan through the column number. Okay, column number 0 index 0, then 1, 2, 3. This is you fix the row index 1, and then you scan through 1 plus 3 plus 5 plus 7. Okay, same to the column. Okay, if let's say you are required to calculate the total for the fourth column, then you have to fix the column index, which is 3. Then you scan through the row number 1, 2 and 3. Okay, 8 plus 7 plus 16. Okay, meanwhile, if let's say you want to scan through the whole array, then we have to be flexible using this nested for loop. Okay, we are not going to fix any row or fix any column index. Okay, you can use either row or column as your inner or outer loop to perform the calculations. If the outer loop is row number, meaning that we are going to scan the first row, okay, then moving from the column to column. Once the scanning is done, then we have to move to the next row, repeat the same process, and then finally move to the last row. Okay, we can also perform the same thing using column by row processing, where we use this column as outer loop first. Then we start to scan from the first column, then move from the row to row. Done, then we move to the second column, third column, and then last column. Okay, now we are going to move on to this most important subtopic for today: how to pass array to a functions and how to return an array from a function. In the previous chapter, you have learned how to pass a single variable or value from one function to another. Now we will see how to pass the whole array with these multiple values from one function to another. We have two parts here. You can either pass only single element from an array to another function, or you can pass the whole array to another function. Okay, now look at this examples where we are going to pass a single values into another functions. So we have this display functions, okay, and this data type for the individual elements in the array is the integer. So we state the data type here. Okay, now we call the functions. So if let's say you are going to pass only a single element, then you have to state clearly what is your index value 1 and 2. Okay, means that you are going to pass the value 8 and value 4 into this h1 and h2, just like normal variable declared as this formal parameter. This h1 and h2 are the formal parameter that receive the value from this main function. Okay, you have to state very clear what is your index number, index value here, just like normal passing the value that you have learned in the previous chapter, chapter 9. Okay, meanwhile, let's say you would like to pass the whole array instead of just individual elements from one function to another, then you have to put this, okay, bracket. Okay, this indicate you are going to receive whole array. Okay, but however, you are not required to indicate the size. Okay, so during this function call, you have to indicate the name of the array h, but without the bracket anymore. If you would like to pass the whole array, just indicate the name. Then you will pass the whole array here to this h. In this formal parameter, you have to show this bracket to indicate that you are going to receive a whole array from the main function. Okay, here is the comparison between the passed individual elements and the whole array to another functions. Okay, so for function declaration, just like the normal function declaration that you have learned in the previous chapter, just the difference for this whole array. If let's say you would like to pass the whole array, then you have to indicate this bracket. This bracket here means that you are going to receive the whole array. Meanwhile, for the array passing, in your individual element, you have to state very clear the index number. Meanwhile, for whole array, you just put this name of the array. And then for your function header, you have to indicate, like as usual, the formal parameters without the index number, no. Okay, meanwhile for the whole array, you have to indicate the bracket, okay, to indicate that you're going to receive the whole array from the main functions. Another important features of this array is actually a pointer. So why do I say so? Look at this example. Okay, we are going to pass the whole array base, okay, into this function multiply 2. Alright, I am going to pass the whole array. So before I pass the array, so this is the value 37158. So I pass these 5 elements into this multiply by 2. Then I perform the calculations. I multiply these elements, each of the element by 2. So I print out the value inside these functions. So this is what I get: 6, 14, 2, 10, 16. Then I stop here. I didn't pass anything back to the main functions. However, if let's say I reprint again, okay, I reprint again the value in the main function, you will notice that the value in this array actually changed. Although I didn't send back this multiply function to this main function, I didn't send anything from this multiply 2 to the back to this main function, but however, the value inside this array changed. Okay, why? Because array name is actually a pointer. This multiply 2, this x, okay, this x here is basically pointing to the array name base. So anything changed in this multiply 2, it will change the value for the array base automatically. So this is another way to pass back the whole array from one function to another using this pointer. So in the previous chapter, we have learned how to return a value in the integer data type, in double data type, or void, means that you return nothing. But in array, we can't pass back the whole array back to the main functions. Okay, in order to pass back the whole array, we have to use the pointer, where we pass back the address instead of pass back a single value. Okay, so look at this example. You are required to generate 5 random numbers, create a function to generate 5 random numbers and store inside an array. Then you have to pass back this whole array back to the main function and display the value. Okay, as I mentioned, we can't actually pass back the array back to the main functions. Instead, you can only pass back the address. Okay, how to do that? You have to use pointer. This is the pointer syntax for the pointer. Okay, and remember what does it mean for this data type? This is basically the data type for the return value. Means that your return value will be in address instead of in the value. Okay, so look at this main function first. Now you're declaring this R. R again is a pointer. Pointer is a variable that's storing address. Okay, but we don't know which address is storing. We don't know yet. Okay, never mind. We go to the line 9. Get random. We are calling a function. We call this get random. Go inside this get random. You are creating these 5 elements. 1, 2, 3, 4, 5. Okay, assume that it's having the address 001, 0002, 3, 4, and 5. Alright, and then I use this srand. This is to generate a random value, okay, which I explained in the chapter 7. Please refer back to the chapter 7 to get more information about this random number. Okay, so for instance, I create a random number for instance now. Okay, you have this first value, second value, third, fourth, and fifth. So like 4, 5, 5, 5, and you have 1, 3, 2. You have 5 random number storing in a different address. Okay, 001 to 0005. Right, then you return RDM. You're not going to return a value. Notice that the return data type is in pointer, means that you're going to return the address. You return the address back to the line 9, means that you are pointing to this 0001. So this now R is having the value of 0001, address value 0001. Okay, now move on to this line 10. This line 10 and line 11 is basically to retrieve the value from this array. RDM. Now this Ri. This Ri is basically equal to get the content. So the first one is index start from 0, right? Start from 0. So it's basically you will get value of 4, 5, 5, and so on. And then you use for loop, right? So increase by 1s. So it become index 1. You will get 1, 3, 2, 3, and so on. And then you repeat until you get R4. You get 1, 7, 7, and so on. This is how we pass the whole array from one function to another using the pointer. So that's all for the array chapters. So I hope that you learned something new today, and I will see you in the next lessons. Okay, bye.